Okay, we are moving on with some more probability. So this time we are going to look at independent and dependent events. Okay, this is where you have more than one event that's going to occur. You're going to do 2, maybe 3 different things. And sometimes what happens on the second event is impacted by what happened on the first one. Sometimes it's not. So what we're going to remember is that when we are doing independent and dependent events, we are going to multiply the probabilities of these events. Okay, tomorrow, or we will be talking about disjoint and overlapping, which is going to be some adding and subtracting. But with these, just kind of like the fundamental counting principle, you multiplied your stuff together. These, your events, you're going to multiply them together as well. So it's used when calculating probability of 2 or more different events happening. Okay, independent events, okay, means that one event does not affect the other one. For example, rolling a die and picking a card from a deck. What you get on the die does not in any way impact what card you're going to pick out of the deck of cards. They are independent from each other. Or picking a card from a deck, putting it back in the deck, and picking another card. Okay, so if you are putting it back in the deck, that means the first time you picked, you had 52 cards. The second time you pick, you still had 52 cards. So those two would make it independent events. And to calculate the probability of independent events, basically this is just some notation here. You're going to have the probability of event A, and you're going to multiply it by the probability of event B. Okay? And dependent events means that one event does impact the other. So we've got a little mistake here on my notes that I'm noticing is if you draw a marble from a bag and you do not replace it in the bag and drawing another marble. That means that if you don't put it back in the bag, there's one less marble in the bag for you to pick the second time, which means that depending on what you got the first time, that's going to impact what you get the second time. And then drawing a card from a stack of cards, not replacing the card in the stack, and then drawing another one. So with a deck of 52 cards, you pick one, you don't put it back, you draw another card, now you only have 51 cards to choose from. So depending on what you got the first time is going to impact what you would get the second time. And to calculate the probability of that is the same thing. You're just going to multiply the probabilities together. The second one, the probability of B given A, means that you're going to calculate the probability of the first event times the probability of the second event without A included in there. Or assuming that if you wanted the probability of getting a Jack of Hearts, you assume that you got the Jack of Hearts the first time and you don't put it back and you draw another card and calculate your probability from there. So let's look at some examples here, okay? So you flip a coin and draw a card, okay? From a stack of 3 red, 5 blue, 6 yellow, and 2 purple cards. So the question is it independent or dependent? So we have a coin and a stack of cards. Does what you get on the coin in any way impact the deck of cards? No, it does not, which means those two things are independent of each other. So what is the probability of getting tails and a yellow card? So we have the probability of tails, and remember this is where we're multiplying, times the probability of yellow. So the probability of tails, well, if you flip a coin, the probability of getting tails is 1/2. And you're going to multiply it by the probability of a yellow card. Well, there are 6 yellow cards out of 16 total, because you have 3 plus 5 is 8, 8 plus 6 is 14, plus 2 is 16. So you have yellow cards. There are 6 out of 16 that are yellow, and you just multiply those two together. Multiplying fractions, you can do those on your calculator, is 6 out of 32, which is going to simplify into however the homework wants it, as a fraction, decimal, percent, anything like that. You can always simplify it. Okay. A cooler of drinks contains 10 Mountain Dews, 15 Diet Cokes, 12 waters, and 8 Gatorades. You pick a drink, don't like it, so you put it back. That's the key word there, is you put it back, which means there are the same number of drinks in that cooler the second time as there are the first time, which would make this one independent. okay? And the probability, we want a Mountain Dew, then a water, okay? So I pick one, my probability of a Mountain Dew, there are 45 drinks in the cooler. If you add up 10 plus 15 plus 12 plus 8, there are 45. So the probability of a Mountain Dew, I'm going to call that MD, times the probability of a water, okay? Well, there are how many Mountain Dews? There are 10 Mountain Dews out of 45 times waters. There are 12 waters out of 45. And when you multiply them together, you get 120 out of a very large number, 2,025. And again, on your class kick, it will probably ask for a simplified fraction, which you just put that into your calculator and it will simplify it for you. And then it also will want a decimal and a percent. You just divide them, have your decimal, and then move your decimal over to find your percent. And then a bag of candy. Here we go. We're going to draw some candy bars. 5 Snickers, 6 bags of Skittles, 4 bags of M&Ms, and 10 Twix bars. You pick a piece of candy, eat it, and then pick another piece of candy, which means the second time you go, there's one less piece of candy in that bag because you didn't replace it. So the first time there would be 25 bags of candy in there. The second time when you come back, there's only going to be 24. Okay, so this is dependent because what you got and what you ate the first time will impact what you actually pull out the second time when you go to take your candy. So what's the probabilities that you do Skittles, then Twix? So we're going to have the probability of Skittles times the probability of a Twix. Of course, we know that when we're seeing if we're going to pick a Twix out of the bag, that second time we know there's one less piece of candy in there. So my probability of a Skittles, well, there are 6 bags of Skittles out of the 25. Twix bars, there are 10 Twix bars, but now this is the dependent part. There's only 24 bags of candy in there. So you'd have 60 out of 600, which again, you can use your calculator to simplify, make into a decimal and a percent. One last example here. We have drinks. I think this is the same cooler as before. It's still got 45 drinks in there. However, this time you pick a drink, you drink it all and throw away the bottle. So now there is one less drink in the cooler than there was before, which means this one is going to be dependent. Okay, so what's the probability that you choose a Diet Coke, then a Gatorade? So the probability of a Diet Coke is going to be 15 out of 45. A Gatorade, there are 8 Gatorades, but now when you're choosing the second time, there's only 44 drinks in the cooler, which means you're going to have 44 in your denominator. When you multiply, you get 120 out of 1980, and then you can make those into your decimal and percent. This is not your homework. Your homework is a class kick called Independent and Dependent Events that needs to be completed in class today. It's called Independent and Dependent Events. So if you would, please make sure that that gets completed in class and just follow the directions on each slide that tells you how to make your answers, whether it's supposed to be a fraction, decimal, or percent.